Okay, so this lesson is on partitioning a directed line segment. The word partition means to separate or to divide, and a line segment with endpoints A and B can be partitioned by another point into a given ratio. So a ratio is a comparison of two numbers. Often you'll see A to B, A over B, or A to B written out, and that's a comparison of two numbers. And if a segment is divided with its midpoint, then it is partitioned into a 1-to-1 ratio. 1-to-1 because each part is equal to the other. So a directed line segment AB is a segment that represents moving from point A to point B. And this is important when we talk about partitioning a line segment because we need to know which endpoint we're starting at. So the following example shows how to use slope to find a point on a directed line segment that partitions the segment into a specified ratio. So if we read the problem, it says find the coordinates of point P along the directed line segment AB so that the ratio of AP to PB is 3-to-2. So AP represents 3 and PB represents 2. So a ratio of 3-to-2 means that there are 5 equal parts of the line segment, and that AP will be 3/5 of the line segment, and PB will be 2/5 of the line segment. So it's not a midpoint, it's going to make one part a little bit bigger than the other, but now we want to calculate this. So we're going to use these points to calculate slope. So the slope of segment AB is the difference of the y's. So we're going to do 8 minus 2 over the difference of the x's, 6 minus 3. And this gives us 6/3. Now, when we're partitioning, we do not simplify the slope. We leave it exactly as is. So from this, we see that we have a rise of 6 and a run of 3. And remember, rise goes to the y-axis and run goes to the x-axis. So we're going to start at point A, and we're going to move in the direction of point B, and we want to do this so that AP is 3/5 of the segment. So P is going to have an x-coordinate equal to the x-coordinate of point A plus 3/5 of the run, which is 3, because the run is used to move along the x-axis, but we don't want to go the whole run, we want to go 3/5 of the run. So that means point P will have an x-coordinate equal to 3 plus, and 3/5 times 3 is 9/5. And we will continue simplifying this. P will have an x-coordinate equal to 3 plus 1.8. So the x-coordinate of P is 4.8. Now we want to do this again for the y-coordinate. The y-coordinate of A starts at 2, and we want to move 3/5 of the rise, but now the rise is 6. And this gives us a P with a y-coordinate equal to 2 plus 18 over 5. And this P has a y-coordinate equal to 2 plus 3.6. So we have a P with a y-coordinate of 5.6. So that means we can say that point P has coordinates 4.8 and 5.6, and that will represent 3/5 of the distance from point A to point B. And if we try to plot this on here, so 4.8 is almost at 5, and 5.6. We're going to go up 1, 2, 3, 4, 5, a little bit past a half, and that's the approximate location of point P. And we should see that AP looks like it's a little bit bigger than BP. So here we have a couple of examples for you to try on your own. We really don't need the graph to do this. So we're going to do this again. We want to find the slope of the line segment. We want to find out the fraction moving from A to B, and that's going to be 4 over 4 plus 1, so we get 4/5. We're going to plot a new point, P, and the x-coordinate is going to be the x-coordinate from the first point. The first point is A. Directed line segment AB means that A is the starting point, so I'm taking the x-coordinate from A. I'm going to add to it the fraction 4/5 times the run. Well, remember that slope is rise over run, so our run is 7. And this gives us a point P with an x-coordinate equal to 1 plus, this is 28 over 5. This gives us point P with an x-coordinate equal to 1 plus 5.6. We have a point P with an x-coordinate of 6.6. Now we will do this again for the y-coordinate. We start at the y-coordinate of A, which is 3, plus our fraction is 4/5, and now the rise is 1. This gives us a point P with a y-coordinate equal to 3 plus 4/5. This gives us a P with a y-coordinate equal to 3.8. So our point P has coordinates 6.6, comma, 3.8. And that means that AP is equal to 4/5 the length of segment AB. So I'm going to say pause the video here. You try problem number 2 on your own, and then unpause it after you've finished so that you can compare your results. Okay, so you've unpaused the video. We're going to look at problem number 2. We want to start by finding the slope of AB. So that is 5 minus 1 over 4 minus a negative 2. This gives us 4 over 6. And remember, do not simplify the slope. Whenever we're partitioning, we want the slope exactly as it is. We need that to get the answer right. Now, the ratio we're working with is going to be 3/10. We want the distance from A to P to be in a ratio of 3 to 7. So 3 plus 7 is 10. That's the denominator. 3/10 means that AP will be the smaller part of the segment. So now we want to calculate the x-coordinate for point P. It is going to start at the x-coordinate for point A, so negative 2, plus our fraction is 3/10 times our rise over run. The run is 6. We use the run with the x-coordinates, and we can say that this point P has an x-coordinate equal to negative 2 plus 18 over 10. And we can say that this point P has an x-coordinate equal to negative 0.2. Then we will do this again for the y. We start at the y-coordinate for point A. We add to it our fraction, 3/10 times the rise, which is 4. This gives us a P of y equal to 1 plus 12 over 10. And P of y is equal to 2.2. So point P has an ordered pair of negative 0.2, comma 2.2. Okay, so use this video to help out with the homework with directed line segments, and refer back to it, follow along, and do these steps with your problem.